Happy birthday to you. Happy birthday to you. Happy birthday, happy birthday, happy birthday to you.
Cha cha cha. Happy birthday, Abby Bossinger. And for anybody else whose birthday we may have missed, we just, the announcements are back on. So now we kind of know. So if we missed your birthday in the past, we're really, really sorry. But happy birthday to you too. And happy birthday, Abby.
Summer birthdays that were this summer. I think it was Alyssa and Emily, which you are like birthday twins. Woo!
So happy birthday, everybody. Speaking of happy birthday, Abby Bossinger. Hello, everybody. Who do we see? I see Michael Jackson. Ow! Oh, what a thriller to have him here today. You can't beat it.
Darius was here first. A big shout out / knockdown to Supreme Ginger, finally showing back up here again. Whew. Dom is here, of course. We've got Alexia here. We've got Zuli, Hannah, Eli, Emily, Radika, William, McCoy / Hatfield. Abby, of course, the happy birthday girl, Abby F, Annie, Maya, Carissa, Haley, Gladys.
I'm sorry.
No, it's good.
I love that. Was that everybody? I think Gladys.
Connor's here. Gladys. People popping in last minute.
Should we just go ahead and say hi to the lurker because
Yeah, is she here? Is the lurker here?
Probably lurking. Who else? Come on, people. Say hello.
Hello.
So, how do you want to do this today? Because we're probably not as planned as we are. We want to do. We want to kind of review one thing just to make sure it's sticking and that you get it, and then we want to go over the worksheet that we gave you yesterday. So if you haven't picked up on this, and some of you have, we've been trying to go over things, give you something to do, and then go over what you're doing in case you're having trouble with it. We do not mind if you're turning things in after we go over it. So typically we would want you to do it, and we want you to try it before we go over it. But if you want to wait and make sure that you understand it, that's fine.
Remember, on Tuesday of last week, anything that was last week's work, this Tuesday I moved everything down. So if you sent it to me at 3:30 or later yesterday, and it was last week's stuff, 50%.
Yeah. So worth doing. Those grades add up, and you shouldn't. It's OS and you, but you should still do it. But we have to start giving you motivation to get it done, so we're not grading the same stuff for ages. Do you want to go over that little thing first, or you want to go over the
I can go over that.
Or would it be better to go over the worksheet first and then go off of that?
Whatever you want me to do.
You tell me.
Do.
Let's go over the worksheet first, because then maybe you can use that to help you go over the other thing.
Okay.
All right, let's do that. We're gonna reverse it. As soon as I can find it. Here it is. Here's the worksheet we gave you yesterday. And I am going to make that full screen. Not that it really mattered, I guess. So it might be kind of hard for you to see. We'll do our best. So the directions for this were put the things on the right side and the left side in order, then draw arrows. Some of you drew arrows without putting them in order. And that was ugly to look at. How am I supposed to check that, right? So let's start by putting things. All right. So I think the easiest thing, here's how I'm going to do it. I'm just going to grab all these on the left side and just kind of move them down out of my way a little bit, right? And then I'm going to look at the cell. There's no interface here because I don't see the DNA on one. So we're going to start with prophase, and we're going to start with prophase 1. So I'm just going to real quick slide that up. That's going to be first. And then what do we have next? It looks like there isn't there is an interface. So guess what? Your teacher was wrong. We're going to put interface first. And so I can still see there's a nucleus here. And here's the big tip off. I only have a chromosome, but it doesn't have sister chromatids. So if we were really going to get nitpicky about this, this is probably right after cells divided before they would doesn't matter. We'll call it interphase. Then prophase 1, lining up the homologous pairs in the middle. So in the middle, so we're talking metaphase, and this is the first metaphase. So I'm going to go metaphase 1. All right, looks like we're starting to pull those apart. So that would be anaphase 1. All right. Got the cleavage furrow. Looks like we're making new cells. So I'm going to go with telophase 1 and cytokinesis. Thanks. Now we're in the second part. We have new cells. So I'm going to guess prophase 2, right? We can see that crossing over that Mrs. Smith talked about. It's hard to see, but I can see. You probably can't see it on the YouTube screen, but on your document, you'll be able to see there's like little pieces of different colors on one of those sister chromatids. We got them in the middle. So metaphase 2 for middle. Now we're starting to pull them apart. Anaphase 2. And then finally, telophase 2 and cytokinesis. Boom. I love on this program how it kind of helps you line everything up a little bit too. Not that it's really that important. I'm going to go up and change this line to an arrow. I'm going to take it on the arrow, and I'm just going to make some arrows. I don't know why we told you to do this. I guess if you had them. But you know what? It takes 3 seconds. You don't have to be perfect about it, but it's really easy to put the arrows once we did that, right? Once we got those in order. So let's try and get this side in order too. This is a little bit harder, right? So I think we're going to read them. Homologous chromosomes line up at the equator. So homologous chromosomes, that's going to have to be in prophase 1. And lining up at the equator, we know is going to be metaphase. So I'm going to move him up right next to metaphase. 2 daughter cells. Okay. 2 daughter cells would be right here. And you know, that's not right. Do me a favor. Mrs. Smith, you might need to pop in here because you know when you're doing this live, sometimes your brain doesn't work. But I have a feeling that 2N diploid should not be there because a diploid, and this is kind of what Mrs. Smith is going to go over, diploid and haploid, if we just split that and there's a different chromosome, split the homologous pairs, it's not diploid anymore, is it?
So the hard part about this in meiosis, and this is where it gets tricky, you know how you talk about the fact that you have chromosomes and there's 2, but there's sister chromatids. And then when you split that tetrad of chromosomes, it's then still a diploid number. I don't usually teach that till AP. So I think it's better if we take it out, but the diploid is not technically wrong. That's kind of a wary situation there.
Is that because this is showing like cytokinesis right here at the end of telophase 1?
Yeah.
But does that always actually happen right there?
I don't understand what you're asking.
Or doesn't that total cytokinesis sometimes wait till? Never mind. Let's not talk about it. We'll confuse the kiddos. All right, sister chromatids pull apart. Sister chromatids, not homologous chromosomes. Sister chromatids. This is why Mrs. Smith and I like biology because no matter how much you know, there's still things you can question. So pulling apart, pulling away, apart, anaphase, and since it's sister chromatids, not homologous chromatids, that's going to be down in 2. Chromosomes line up at the equator. And then the next one's homologous chromosomes. So chromosomes lining up at the equator, not homologous, lining up metaphase 2 because it's not homologous. Homologous chromosomes pull apart, away. That's that anaphase thing again. So I'm going to drop that guy up there. 4 daughter cells. And this does say N haploid. And we can leave that one. That one is correct. So look at me being a little bit whatever, trying to get these things lined up a little better. All right. And then the last thing we have to do, go back, get our arrow, and just make sure that we say, I know it's that cell. 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 I know it is that cell. And I know it's that cell. And that's all it is to it. And that took us about 5 minutes. So Come on, guys. You can get this done. And what I am not going to do is save and close that. Because if I save and close it, that would give you all the answer. So I'm going to hit that button and hit leave and just go back and make sure that I didn't just mess that up. Nope, it's still good. And the last thing I'm going to do before I turn this over to Mrs. Smith is grab that attendance forum link and stick that in the chat because I forgot earlier. All right, Mrs. Smith, do you want to talk about that other stuff? By the way, we're out of t-shirts, but where is it? We're still Hanover Public School District. The first polo shirt that I have put on since Friday when we walked out of school, ladies and gentlemen. This is how much I love you.
Intense. All right. So what I did with my handy dandy whiteboard while Mr. Shooter was talking is I tried to start going over things. So I'm going to chill a little bit. Maybe there we go. Okay. So the first thing I want to point out is we're talking about mitosis versus meiosis. Now, if I were at home and I was trying to figure all this stuff out for myself, I would do one of our handy dandy Venn diagram. So if you are confused and want to go over things, that's a great tool to use. We could do one together potentially in like a Zoom tomorrow if you want to. But anyway, like I'm saying, I'm looking at the difference between mitosis and meiosis for you. Or not a Zoom tomorrow, Zoom Friday maybe. All right, so what I'm starting off with is I always underline the T in mitosis because that reminds me that at the very end I'm going to have 2 cells. Meiosis is making more of me, okay? Those sex cells, those gametes, making more of me. Both cells start off in interphase, okay? Both of them start off in interphase, which means that if we're talking about chromosomes and we're talking about the number, how many chromosomes does a human cell have in a regular human cell? How many you got?
That sounds like a question for the chat.
It is a question for the chat. How many you got in your cell?
Our numbers look low today. We must have some lazy people out there, or the birthday monkey scared them all away. I don't know.
Maybe it's the video yesterday.
the Meiosis squared ants.
Yeah. Do 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 do.
We can show that again.
Do 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 do.
How many chromosomes in a human cell? Is that what you asked?
Yes, I did not think that was going to be difficult.
You gotta wait for them. You gotta wait for the 10-second lag time, and then you gotta.
I don't know. I just got like 6 meiosis worksheets shared with me, so I'm thinking that what people are doing is finishing up the assignment that they didn't do as we went over it, and now they're sharing it with me. So
46 we see in the chat from Eli Zulika, Darius Zulika.
All right, good. All right, so at the very, very, very beginning in G1, whether we're in meiosis or we're in mitosis, in G1, whoop, we have 46. When we go to the S phase, when we finish the S phase in interphase, how many do we have? It's like math. Don't forget to carry your numbers. How many? Nine to 2. Good. Okay, so we have 92. We now have double mitosis and meiosis, the same. So in G2, we still have 92. Nothing else has happened. As we go into prophase, we have 92. In prophase 1, because it's a little bit different, we have 92. Still the same. As we go through prophase, metaphase, anaphase, telophase, and cytokinesis and mitosis, We then flip back to interphase. How many chromosomes for a human, because different for every organism, okay? How many chromosomes are in the interphase of mitosis? Anybody? How many? How many? It's really either really laggy or I'm asking a lot of you. 46. Yes. 46. Don't ask it as a question, Darius. Yes, 46. We have split them into two. Look, here's 46, or sorry, here's 92, split evenly. And we've got 46 in this one and 46 in that one. Remember that we want the cells identical to how we started. So if we had 46 beforehand, we want 46 afterwards in mitosis because we went, in total. Okay, I understand what you're saying, Eli. No. In each cell. I'm sorry. My bad. So we have 46 in each cell there. So let's say there was a question that said in mitosis, the fruit fly has 4 chromosomes, because that's what it has, 4 chromosomes in its skin cell, How many does it have after mitosis? So if it started with 4, how many does it have at the end of mitosis? 4. Okay, good. All right. Now, if we switch over to meiosis, okay, again, we've still started off with the 46 with the G1. We've still done the S phase, okay, with 92. We still have G2 at 92. We've still gone through the entire interphase that we regularly have. We go through prophase 1, and we go through metaphase, anaphase, telophase, and cytokinesis. So in each of the cells, as it goes into prophase 2, because remember, there is no interphase 2 or anything like that. It doesn't go back into interphase. Okay? So the same as it is in mitosis, each of these cells in prophase is at 46. But if this is where your gametes stopped, then if mom gave you 46 and dad gave you 46, you would then have 92. So we actually have to split it again, which is why we go through meiosis 2, prophase 2, metaphase 2, anaphase 2, telophase 2, and cytokinesis 2, so that in each of these cells, we wind up with how many? How many does your gametes, sex cells, sperm, egg have in each one of them? 23. Good. So 23 in this one, 23 in this one, 23 in this one, 23 in this one. The difference, besides it being half, okay, if we go back to my little Venn diagram up here, we're talking about it. Okay, so for mitosis, these are genetically identical. These are genetically different. Okay, meiosis is genetically different cells because in prophase 1, remember we've had crossing over where they exchange some information. In metaphase and anaphase 1 and 2, we have independent assortment. So where they are lining up changes every single time, which then leaves you with different gametes for every single one. Okay, so there's a quick kind of chart going over the numbers. Okay, so again, if I told you that a fruit fly has 4 chromosomes in a regular cell, how many chromosomes are in a gamete for a fruit fly? Two. Good. Thanks, Eli. Dom's got it. Okay. So not every organism has the same number. I used humans. I used fruit flies. Okay. But it might say on there, that a horse has 32 chromosomes. How many is in a horse gamete cell? So that's just kind of some of the things that you need to be able to think about as the whole picture. So hopefully that kind of reviewed the difference between mitosis and meiosis a little bit. Mr. Shooter, did I miss anything that you want to add?
Nope. Awesome. Awesome. So anything else? Or is that it for us today?
Yeah. Tomorrow we're going to do a little game, right? To review here.
Yeah, I mean, if you don't, just so you full disclosure, we are trying to stall a little bit. We're ready to go into genetics. We want to give you time to finish working on the assignments in mitosis and cell cycle that you haven't completed. So in doing that, we spent a whole day going over the assignment. Mrs. Smith kind of reinforced that. Tomorrow we're going to play a game. Friday, maybe a Zoom session, something like that. So with that, I think we're done.
Shay said she had a question. I'm sorry. I'm taking a picture of what I just drew. I thought that might be helpful. I'm going to stick it on my Moodle as an image. So if you want to look at that, I'll put it in there. So Shay, what's your question?
Keep that out to HPSD. Awesome.
Woo.
If you have a question, you better ask it quick. We're getting ready to sign off.
Yes, please do. Yes, I got a ton of them while we were on this live stream. Please, please, please. That's still full credit. It's everything from last week that moved into the half credit, and I'll still accept everything. It's just whether or not you're not getting full credit. Hey, turtle population's up since people aren't on the beaches. Woo! Because Darius said, bye guys, remember to wash your hands and save the turtles. We're saving the turtles right now. Lots of turtles on the beaches. It's good.
That's great. All right, everybody. Well, have a good day. As always, stay safe, wash your hands. We love you. And just remember, you never realize what you had until it's gone. Toilet paper is a good example.